Hello, Algebra 2 students. In this video, I'm going to be going over all of the problems on your Marking Period 3 Progress Check Review. So you can either, some of you maybe have already done the review by yourself, and then you're just watching the video to compare your answers and fix any mistakes you have. Or some of you are maybe doing the review while you watch the video, copying down my work and answers. That's also totally fine. Either way, whatever works for you to help you best prepare for the progress check. All right, so in the first question, we are given a graph of a rational function, and we need to decide which equation best matches the graph. So one of the most helpful characteristics of a rational graph we can look at is the asymptotes. So I'm going to start by looking at the vertical asymptote, which I see is at x equals 4. So when I have a vertical asymptote at x equals 4, the vertical asymptote is always found in the denominator of my rational function, but the sign is always switched. So if I have a vertical asymptote at x equals 4, that means that my denominator should say x minus 4. So it's always the opposite sign for the vertical asymptotes. And the reason for that is because the vertical asymptote is at the value where I would have a 0 in my denominator. So this should be a number where if I plug it into the denominator of my function, I get 0 in the denominator. That's why we have the asymptote at the undefined value. So I'm going to be looking for a function with x minus 4 in the denominator so that the sign is flipped. And I can see I have that in option A and in option C. But I do not have that option. I do not have x minus 4 in the denominator for B or D. So I can definitely eliminate B and D. All right, we're still going to have to decide between the two. So let's check the horizontal asymptote now. The horizontal asymptote is at y equals 1. So it's at the y value of 1. And the horizontal asymptote is always at the end of my equation, and the sign should always be the same, so we don't flip the sign for the horizontal asymptote. So I should have a plus 1 at the end of my equation, and I actually see that in the first 3 options, but we already eliminated option B, and option A and C both have the correct plus 1 at the end, so we still haven't decided whether the answer is A or C. It's definitely not D, though. Now, if I go on, I'm going to figure out the main difference I can see between A and C is I have a negative 2 on top in the numerator for A, and I have a positive 2 in the numerator for C. So we know that the 2 is correct because the 2 tells us that the points on our graph are up 2 over 1 and down 2 over 1. But the positive negative has to do with what quadrants we're in. So I always focus on whether the right branch is above or below the horizontal asymptote. If the right branch is above, then it's a positive A value, a positive value in the numerator. If the right branch is below the horizontal asymptote, then it's a negative A value in the numerator. So since it's above, we should have a positive A value. So we need A to be 2. So not negative 2, but positive 2. So that would have to be option C. So option C is the correct option. It's got the x minus 4 in the denominator for our vertical asymptote at positive 4. It's got the plus 1 at the end for the horizontal asymptote of y equals 1. And the positive 2 tells us that we have branches in the top right and bottom left quadrants. And the 2 tells us that we have a slope of 2 for the points on each branch away from the center of the asymptotes. All right, we're going to do another one just like this. Different graph. So again, I'm going to start with my vertical asymptote, which is at the x value of negative 3. So x equals negative 3. That means my denominator should say the opposite, x plus 3. And I only have that in options B and D. So I'm going to eliminate A and C. My horizontal asymptote is at the y value of negative 2. So y equals negative 2. So that means I need to have a minus 2 at the end of my equation. I have that in 3 of my options. I already eliminated option C. So I'm still choosing between B and D because they both have the minus 2 at the end. And then I'm going to go on to figure out what number I should have in my numerator. So again, I'm going to look at the slope to figure out the value and then the quadrants to figure out the sign. So I see that this point is down 1 over 1, up 1 over 1. So that means I should have the value of 1 in my numerator, which I do. I have all 1s, but it needs to be a -1 because, again, on the right side, the right branch, it's below the horizontal asymptote. If it was above, then it would be a positive a value, but that right branch is below the horizontal asymptote, so that reminds me that I should have a negative value in my numerator. So that means it has to be option B because I was between B and D has a +1 in the numerator. So my correct option is option B, okay? All right, so now that we've gone over our rational graphs, let's go on to the next page, more multiple choice. This time we are figuring out the quotient of 6x plus 1 divided by 3x plus 2, and we're going to do this by long division. This is the same process we used when we were converting rational functions from standard form to asymptote form. The way the question is being asked is just a little bit different. So we start by setting up our long division, and the 6x plus 1 goes underneath, and we're dividing it by 3x plus 2. Step 1 is to figure out how many times the first term on the outside goes into the first term on the inside. So how many times does 3x go into 6x? One way you can do this is actually dividing 6x by 3x and seeing what you get. Another way to think about it is 3x times what gives you 6x. So either way. So if I divide these, 3x divided by 6x, the x's cancel out. 6 divided by 3 gives me 2. That would make sense here as well because 3x times 2 would give me 6x. So some people like to think about it different ways. I think the easiest way is to take the first term on the inside and divide it by the first term on the outside. So 6x divided by 3x gives us 2. So I put that above the 1 because they're both constants. There's no x. All right, my next step is to multiply. So divide and then multiply that number by both terms on the outside. So 2 times 3x gives me 6x. 2 times 2 gives me +4. Now I have to subtract both of these values from my 6x plus 1. So I have to subtract both. Don't forget to subtract both. 6x minus 6x cancels out. That first term should always cancel out. And then 1 minus +4. That means 1 minus +4 gives me -3. This is where a lot of people forget to subtract that value. So I'm subtracting 1 minus 4. That gives me -3. My next step would be to say how many times does 3x go into -3, but that's not going to work because 3x can't go into -3 at all. That's my remainder. Okay, so then my answer should be 2 plus -3 over 3x plus 2. I can also write that as 2 minus 3 over 3x plus 2. So the number on top is always my whole number. So like this, it's definitely not C because we got a 2 on top. And then my remainder is left over top of what I was dividing by. So the -3 should be divided by the 3x plus 2. So it can't be D because that's being divided by 6x plus 1. That doesn't make sense. Can't be A because that has a remainder of 5. It has to be B. So B, 2 minus 3 over 3x plus 2. Again, some of you maybe would have written this 2 plus -3 over 3x plus 2. That's the same thing as 2 minus 3 over 3x plus 2. So you need to know that that's the same thing. Okay. All right, let's do another practice like that. So once again, 5x minus 2 divided by 5x minus 2 divided by x plus 1. Once again, I'm going to put the 5x minus 2 underneath, and the x plus 1 goes on the outside. First step is to figure out how many times x goes into 5x. That's the same as doing 5x divided by x. which the x's cancel out, gives me 5 over 1, so just 5. Another way to think about it, x times what gives you 5x? That has to be 5. X going into 5x has to be 5 times. So I put the 5 over top of the negative 2 because they're both constants. Next step is to multiply. Oops. Multiply 5 by both of the terms on the outside. So 5 times x gives me 5x. 5 times 1 gives me positive 5. I have to subtract both. Don't forget to subtract both. 5x minus 5x, that should always cancel if you did it correctly. Negative 2 minus 5 is going to be negative 7 as our remainder. So my answer should have 5 as the whole number. So my answer is definitely not D because that's got 3 as our quotient. 5 minus 7 over x plus 1 should be my answer because I'm always putting my remainder over whatever I was dividing by. So my answer has to be C. 5 minus 7 over the x plus 1. The other two had a remainder of positive and negative 3, so that would not make sense. We got a remainder of negative 7. You might have gotten the other two if you had forgotten to subtract the 5. If you just did negative 2 plus 5, that would give you 3. So that would be how you kind of make that mistake. So you really cannot forget to subtract both of the terms from what you have above. So negative 2 minus positive 5. All right, moving on. We're going to practice solving rational equations. The first one is x minus 3 divided by x equals x plus 4 divided by 7. Now, my first step is usually to find my least common denominator. When you have an equation set up like this, where you just have one fraction on each side, you can also cross multiply to solve. I'm going to kind of show it both ways. If I want to do a least common denominator for this, I have a denominator of 6 and a denominator of 7, which are different numbers and they don't go into one another at all. So my LCD would be 6 times 7. So I can multiply both sides by my LCD, 6 times 7 and 6 times 7. And that would cancel out, the 6's cancel out here, the 7's cancel out here. So I would get 7 parentheses x minus 3 equals 6 parentheses x plus 4. As you can see, the numerator on the left ends up multiplied by the denominator on the right, and the numerator on the right ends up multiplied by the denominator on the left. So you can think of it as cross-multiplying when you have it like this, where it's just one rational on the left and one rational term on the right. You can just cross-multiply instead of thinking about the LCD if you want. Either way is fine. Now my next step, of course, is to distribute 7 and 6 on each side. So 7 times x gives me 7x. 7 times negative 3 gives me negative 21. 6 times x gives me 6x. 6 times 4 gives me 24. Now I have to solve for x. I have x's on both sides, so I'm going to need to move. I usually like to move my x terms to the left and my constants to the right, but you could do it the other way around, and you should still get the same answer as long as you didn't make any mistakes. So I'm going to subtract 6x on both sides first. 7x minus 6x gives me 1x. I still have the minus 21, and then I'm left with 24. And my final step would be to add 21 on both sides. And that gives me x equals 24 plus 21 gives me 45. Okay. And then, of course, our last step is we always have to double check if we have an extraneous solution. When I go back and look at my original equation, my denominators were 6 and 7. So I actually didn't even have an x in my denominator, so there would be no way for my denominator to be 0, right? The extraneous solution occurs when the denominator is 0, when you plug in the answer you got. But if I were to plug in 45, I wouldn't even be plugging anything into the denominators because there was not an x down there. So there would be no way to get an extraneous solution for this problem. So x equals 45, not extraneous. All right. Now in this next one, we do have x's in the denominator, so there is a chance we'll end up with an extraneous solution. Once again, you can cross multiply or you can think about the LCD. I'll show it both ways. So since I have a denominator of x plus 3 on the left and x minus 2 on the right, They're completely different denominators. They have nothing in common. So if I want to be able to cancel them out when I multiply by the LCD, I'm going to need to multiply by x plus 3 and x minus 2. So my LCD has to be x plus 3 times x minus 2. Again, if I only multiplied by x plus 3 on both sides, I would not cancel the x minus 2. If I only multiplied by x minus 2 on both sides, I would not cancel the x plus 3. So you have to multiply by both. So then I cancel out the x plus 3's on the left and the x minus 2's on the right. Again, you could have, well, I'll write down what we have and then I'll show. So I'm left with 4 parentheses x minus 2 equals 3 parentheses x plus 3. So you could have just cross multiplied 4 times x minus 2 equals 3 times x plus 3. That's what we got. Again, this only works if you only have one rational term on each side of the equation. My next step is to distribute on both sides. 4 times x gives me 4x. 4 times negative 2 gives me negative 8. Don't forget about those negatives. 3 times x gives me 3x, and 3 times 3 gives me positive 9. Now, once again, I like to move the x terms to the left, so I'm going to subtract 3x on both sides. 4x minus 3x gives me 1x, carry down the minus 8, carry down the 9, and then I need to add 8 on both sides, so I get x equals 17. Now I have to check if this would be extraneous. If I look back up at my equation, if I were to plug in a 17 in for x in either denominator, would I get 0? 17 minus 2 would give me 15, so I wouldn't get 0 there. 17 plus 3 would give me 20, so I wouldn't get a 0 there either. So this is not extraneous. All right. We've still got one more. This one's got more terms. So negative 3 minus 7 over x minus 5 equals negative x over x minus 5. So again, I'm going to think about my least common denominator. I can't use cross multiplication here because I have more than just the one rational term on each side. I have that negative 3. If the negative 3 wasn't there, sure, you could cross multiply, but I have another term on the left side, so I can't cross multiply. So I'm going to think about my LCD. I want to look at the denominators I have. I have x minus 5 and x minus 5. So I have the same denominator. Negative 3 has a denominator of 1, but I don't need to worry about that because there's nothing I need to cancel. Since these two rational terms have the same denominator, my LCD is that denominator they have in common, x minus 5. So I can multiply both sides, sorry, not both sides, all my terms by x minus 5. So don't forget to multiply the negative 3 by x minus 5. Just because it doesn't have a denominator doesn't mean you can ignore it. You have to multiply every single term by your LCD, even if it doesn't have a denominator that you need to cancel. You still have to multiply everything. We have to do the same thing to every term. So for the negative 3 times x minus 5, nothing's going to cancel. We're going to have to carry them both down. For the 7 over x minus 5 times x minus 5, that is going to cancel. And on the right side, it's also going to cancel out the x minus 5. That's the whole point. We don't want to have any more denominators. So I have to carry down negative 3 times x minus 5 minus, don't forget there's a minus, 7. That's all I have left there because the x minus 5 is canceled, equals negative, don't forget that negative, x. All I have left is the negative x because the denominator canceled. Again, don't forget to carry down those negatives. Don't lose those. My next step, just like before, I do have some distributing I can do. So negative 3 times x is negative 3x. Negative 3 times negative 5 would be positive 15. And then carry down the minus 7 equals negative x. I want to combine like terms I have here. So I can combine positive 15 and negative 7. So when I say combine like terms, I mean like terms that are already on the same side. So the 15 and the minus 7, I'm going to carry down the negative 3x. Positive 15 minus 7 gives me 8. Carry down the negative x. Finally, I need to move all my x terms to the same side and my constants to the same side. Normally, I move my x's to the left, but I don't want to move the only term on the right side because then I'll have a 0 over there. Instead, I can just move the 3x by the negative 3x by adding 3x. And that'll save me a little extra time, even though it'll be on the right side. That's fine. So when I add 3x on both sides, I'm left with 8 equals negative x plus 3x. So that's like a negative 1x plus 3x. Negative 1 plus 3 gives me 2. So I have 2x. And then my final step is to divide by 2 on both sides to get x by itself. And so I get 4 equals x. Now I need to think if this would be extraneous. Think about if you were to replace those x's with 4 and subtract. So 4 minus 5, would that give us a 0? No, 4 minus 5 would give us a negative 1. If we had gotten 5 as a solution, that would have given us 0 in the denominator. So x equals 5 would have been extraneous, but we got x equals 4, so it's not extraneous. So we didn't get any extraneous solutions today, but you always have to check. All right. So in this section, we need to do the indicated function operation using the polynomials we're given. So for the first part, we're given f of x equals 2x to the fourth minus 7x squared plus 3, and g of x equals 2x squared plus 4x plus 1. So I'm going to use blue for f of x and red for g of x. Okay. So it's telling us to add f plus g of x. So I'm going to start by writing down f of x, and then I'm going to add g of x, and then we're going to combine the like terms. So f of x is 2x to the fourth minus 7x squared plus 3 plus 2x squared plus 4x plus 1. So I'm just adding all the terms together. That means I need to look for like terms. So my first, I see 2x to the fourth. I'm looking to see if there's any other x to the fourth terms, and I don't see any. Then I see negative 7x squared. I want to see if there's any other x squared terms to combine it with, and I do see that 2x squared, positive 2x squared. Let me circle those again. So the negative 7x squared and the positive 2x squared will get combined. And then the plus 3, I'm seeing if there's any other constant terms to combine with, and I do see the plus 1 at the end I can combine. And then the last thing I see is the 4x, and I don't see any other terms that have just an x. So I'm going to combine all of those. So, and then I'm going to bring down the rest. So I'm going to bring down the 2x to the fourth. It doesn't get combined. Negative 7x squared plus 2x squared, that gets combined. Negative 7 plus 2 gives me negative 5x squared. I need to bring down the 4x. And then I'm going to combine 3 plus 1, which gives me 4. Okay, so that is what I get when I add f plus g of x. You could also do this where you kind of line it up vertically. So when you do that, you would write the f on top, but you would need to leave space for any missing terms. So like I have 2x to the fourth, and then I don't have an x cubed, so I would have to put plus 0x cubed. Then I have minus 7x squared, and then I don't have an x term, so I would have to put plus 0x, and then I have a plus 3. And then my g of x, I don't have an x to the fourth term, so that's a 0. I don't have an x cubed term. I do have the 2x squared and the 4x and a constant. So you can also add them up like that, and then just add vertically the 2x cubed plus 0x or 2x to the fourth doesn't get added with anything, so it stays the same. I don't have an x cubed term. Negative 7x squared plus 2x squared, we combine that to get negative 5x squared. 0x plus 4x, I just get 4x, and then 3 plus 1 gives us 4. So that's another way you could do it if you're lining it up that way. I'm going to keep doing it the horizontal way, especially because we have a lot of like missing terms in between. So I'm going to keep doing it the horizontal way. So for the next one, we have to do f minus g of x. So I'm going to start by writing down f. I'm using blue. So f is 2x to the fourth minus 7x squared plus 3. And then I'm subtracting g of x. So when I subtract g of x, I need to make sure I put it into parentheses because I have to make sure I subtract all of the terms in g of x. So I'm going to put 2x squared plus 4x plus 1. And then we're going to have one extra step where we distribute that negative to all of our g of x terms, because again, we want to make sure we're subtracting all three terms. If we forgot the parentheses, we would only be subtracting 2x squared, and we wouldn't be subtracting the 4x and the 1 as well. So that's why I always put parentheses when I write it the first time. So to distribute the negative, nothing changes with the f of x. And then the negative gets distributed, so I get negative 2x squared. The negative distributes to the positive 4x, so I get negative 4x, and it distributes to the positive 1, so I get minus 1. So all the positives became negatives because we're subtracting all the terms. Now, same thing, I got to combine my like terms just like before. I can combine the x squareds and the constants, and I'm going to carry down the rest. So carry down the 2x to the fourth. Negative 7x squared minus 2x squared gives me negative 9x squared. Carry down my negative 4x, and then positive 3 minus 1 gives me positive 2. That's what I get when I subtract f minus g of x. You don't want to forget to carry down any of the terms that aren't being combined. Okay, my next one, I have two new functions. So f of x is 3x cubed minus 2x squared plus 11. I'll use blue for that again. G of x is 4x squared plus 6x plus 3, and I'll use red for that. Again, the first thing we have to do is add them. So 3x to the third minus 2x squared plus 11. So I copy down my f of x, and then I'm going to add the g of x terms. And I don't need parentheses because I'm not subtracting here, so I don't need to worry about distributing a negative. Now I have to combine like terms, so I start looking at the 3x cubed and see if there's any other x cubed terms. I don't see any others, so that one's just going to get carried down. Then I look at the negative 2x squared and see if there's any other x squared terms. I do see the plus 4x squared, so I'm going to combine those. Then I look at the plus 11 and see if there's any other constants to combine it with. I do see the plus 3 over here. And then 6x, there aren't any other x terms, so I'll keep those. Keep that one, it's just going to get carried down. So carry down the 3x cubed. Negative 2x squared plus 4x squared gives me positive 2x squared. Carry down the x term plus 6x. And then 11 plus 3 gives me 14. All right. And then when we subtract f minus g of x, same thing, except I'm going to subtract, so I need my parentheses. So 3x cubed minus 2x squared plus 11 minus parentheses 4x squared plus 6x plus 3. And I need to start by distributing the negative, so nothing changes with the f of x. And the 4x squared becomes negative 4x squared. The 6x becomes negative 6x. And the 3 becomes negative 3. Now I have to combine everything. So it's just like before. We're going to have the x squared terms and the constant terms. All right. So we carry down the 3x cubed. Negative 2x squared minus 4x squared gives us negative 6x squared. Carry down the negative 6x, and then 11 minus 3 gives us 8. And that's our f minus g of x. All right. Now we are going to review end behavior, looking at polynomials. So for my first one, I need the degree, leading coefficient, and behavior. So to find my degree, I'm always going to, when I'm in factored form, I need to add up the exponents on each factor. If I was in standard form, I'd be looking at the highest exponent I see, but for factored form, you add up the exponents on each factor. So 2 plus 3 gives me the degree of 5. The leading coefficient is the number in front of all of the parentheses, so the negative 4. So my leading coefficient is negative 4. Now I have to describe the end behavior. So it's important for our end behavior, we need to go back and make note of the fact that our degree is odd and our leading coefficient is negative. So we're thinking of an odd negative graph. So I know when I have an odd end behavior, I know that my end behavior is going to be going in opposite directions. And before I write the end behavior statements, I always sketch a little graph to remind me. So if I have, let me draw the two options. If I have a odd degree, I'm either going down on the left and up on the right, or the reverse. Since we have a negative graph, that tells me that the right side is going to go down. So that means I'm looking at this graph, this type of end behavior, where I'm going up on the left and down on the right because it's odd, negative. So now I just have to describe that end behavior in my statement. So as x goes to negative infinity, that's talking about the left side of my sketch. So on the left side, f of x is going, well, it's going up on the left, so f of x is going to infinity. And then on the right side, as x goes to positive infinity, f of x is going down, so f of x is going to negative infinity. So this is positive, negative infinity for y. Okay. Next one, same thing. To find the degree, we have to add our exponents. 2 plus 2 gives us a degree of 4, and we're going to need to know that that's even. Move this. My leading coefficient, I'm going to look at what's in front of all the parentheses. It's 2, and we're going to need to know that that's positive. Describe the end behavior. So I'm going to think about what I remember about end behavior. It's an even graph, so that means it's either going up on both sides or down on both sides. That's how I always remember. Oops. My even graph. So my odd ones are going opposite ways. Even's always going the same on both sides. Since it's positive, that means it's going up on both sides. So this is the end behavior I'm looking at, even, positive. And then I just need to write my statement accordingly. So since it's going up on both sides, f of x is going to positive infinity on both sides, on the left and the right side. Okay. Now, this next one asks us to find the zeros of the function given the graph. So even though we're given the equations, we actually don't really need them because we can find our zeros just by looking at the graph. So if you have an equation and you're able to put it into a calculator and get a graph, or if you're given a graph, just look at the x-intercepts. So zeros mean the same thing as x-intercepts. So I'm going to look at where it's touching the x-axis. So for my first graph, it's touching at -5, -2, and 1. I need to make sure I write in my x-y coordinate form. Y is always 0 for my x-intercept. So -5, 0, -2, 0, and 1, 0. And for my next graph, same thing. I see -5, -3, and -1. So my zeros are -5, 0, -3, 0, and -1, 0. So all it was asking us to do was find the zeros, which means we look at the x-intercepts, and the y value is always 0 along the x-axis. Okay, last page. So given the graph of the polynomial function, place a check mark next to each statement that is true. So we're just going to go through each one and see whether it's true. First one says the graph has an x-intercept at -2. So x-intercept at -2 would be right here, and it looks like it does. It is touching the x-axis at -2, so we'll put a check there. The graph has a y-intercept at 3, so if it had a y-intercept at 3, +3, that would be up here. It would be touching the y-axis at +3, and it is not touching the y-axis at +3. So that is not, I was going to put an x, but I'll put an x so we know. The graph has a y-intercept at -6, so that would be down here at -6. It would be touching the y-axis, and it is, so that's correct. The degree of the function is odd. Odd would mean that it's going up on one side and down on one side, and it looks like it is because it's going up to infinity on the right, down to -infinity on the left. So, yep, it is an odd function. The degree of the function is even. Well, if it's odd, it can't be even. It can't be both. It's either odd or even. So it's definitely not even because then it'd be going in the same direction on both ends. The graph is decreasing on the interval -1.528 to +1.528 on the x-axis. Well, it looks like this point is at -1.528, and this point is at +1.528, and it's saying that it's decreasing on the interval, and we always go from left to right to figure out decreasing, and so yes, it is decreasing. Yes, it is decreasing on that interval. Now we've got some end behavior statements to figure out. It says as x goes to negative infinity, f of x goes to negative infinity. So that would mean on the left side, y is going down. And it is. The arrow is pointing down on the left. So yes. And then it says as x goes to positive infinity, so the right side, f of x is going to negative infinity. So y is going down. That is not true because it's going up on the right side. So that is not correct. Very last one. Given the polynomial function below, determine all three zeros. And the quadratic formula is here, which means we're probably going to need it. So I can always find my zeros, which are the same as the x-intercepts. We can find one of the zeros from x minus 4 because we find zeros by setting each factor equal to 0. And if I set x minus 4 equal to 0, I can add 4 on both sides and I figure out that I have a 0 at x equals 4. So that tells me one of the zeros, but I need the other two. So I have 1 0 at 4, 0. I need to find the other two. So if I want to find the other two zeros, I would have to set this factor, this quadratic, x squared plus 4x minus 6 equal to 0. Now I could do this by factoring, especially because I don't have a number bigger than 1 in front of x squared. It definitely looks like something I could try and factor. So I might try factoring first and see what happens. I'm trying to multiply to -6 and add to 4. Because they're not going to tell me what to use, but I have the quadratic formula available to me. I would list my factors of 6, 1 and 6, 2 and 3. If I'm multiplying to a negative, then one of them needs to be negative, and I'm adding to +4, so the smaller number would be negative. And I'm thinking, does -1 plus 6 give me 4, or does -2 plus 3 give me 4? This would give me 5, this would give me 1. So nothing is working, so we're going to give up on factoring. You can also jump straight. You can solve anything by quadratic formula if you want. So you could also just jump straight to the quadratic formula. So we're going to use quadratic formula. So my a value is the number in front of x squared, so a is equal to 1. B is the number in front of x, so b is 4. C is the number by itself at the end, so c is -6. I'm going to set up my shell, so I write down my quadratic formula, but every time I see a variable, I replace it with parentheses. And then I'm going to fill in the parentheses with the correct numbers. So first I'm going to fill in the b, so b is 4, so it goes here and here. -4a is c, a is 1, c is -6, and 2a. So a is 1, goes down here. Now I just have to simplify. So I have -4 plus or minus square root 4 squared minus 4 times 1 times -6. You could do this in a calculator. You can just type it in as you see it under the square root. I'm going to sort of do it by hand, but you can totally type it into a calculator. 4 squared is 16. Minus 4 times 1 times -6. Well, multiplying by 1 doesn't change anything, so it's really just -4 times -6, so that's going to become plus 4 times 6 is 24. 16 plus 24 would give me 40 over 2 times 1, which is just 2. And then I want to see if I can simplify this any more. So I could simplify this more by seeing if there's any perfect squares that go into 40 and pulling it out of the square root. So we didn't really do this in class, but you can simplify things like this. So I'm going to leave the -4, and then I'm going to think if there's any perfect squares that go into 40. Well, I can think of the perfect square of 4 goes into 40, right? 40 is 4 times 10. And so then I can evaluate the square root of 4 and pull that out of my square root. So square root of 40, it's kind of like square root of 4 times 10. And the square root of 4 is 2. So I can take the 2 out and leave the 10 underneath. So basically I simplified it by taking out the square root of 4, which is 2, leaving the 10 underneath. And then I can simplify this because I can divide -4 by 2 and 2 by 2 and be left with square root of 10. So I can divide basically both of these by 2, and get a final answer. So x equals -4 divided by 2 gives me -2, plus or minus the 2 square root of 10. The 2 is going to cancel out, and I'm left with square root of 10. So that's a little extra challenge to simplify, but it is good practice. So my other two zeros would be -2 plus square root of 10, comma 0, and -2 minus square root of 10 minus comma 0. Okay. All right, those are all the problems on your review. Hopefully this helped, and